Hi, in this video, we are going to be evaluating this expression. Now, this expression is pretty long, so let's break it down into its 5 components, then add each of those together. So let's start with A transpose B transpose C. First, let's write out each of these. Now, if you remember, the dot product of vectors and matrices has the associative property, which means that multiplying these two together first and then multiplying that by C will be the same as multiplying these two together first and then multiplying that by A transpose. So let's do this second part first. We can bring A transpose over, and the dot product of these two will give us 2 plus 0 plus 9 on top, and 0 plus 0 plus 3 on the bottom. This brings us to 2, negative 1, times the vector 11, 3, which comes out to 22 minus 3, which is 19. Great. Let's move on to the second component. This is A transpose A times the vector B. So let's set it up again. And we'll do the same and multiply these two together first. So now this dot product will come out to 6 times 2 is 12, plus negative 1 times 12 is negative 12, which will give us 0. So now let's move on to the third component, which is the trace of AB transpose. Now, just a quick refresher on what the trace is. The trace is the sum of the diagonal of a square matrix. So first, let's get AB transpose so we know what to take the trace of. 2 times 1 is 2, 2 times 4 is 8, 1 times negative 1 is negative 1, and this is negative 4. So now, if we take the trace of this, that will be 2 plus negative 4, and that will be negative 2. Moving on, let's take the Frobenius norm of the matrix A. We actually did this in a previous question, so if you need a refresher on what the Frobenius norm is, please take a look at that. The answer we got from that question was root 14, so we'll just use that here. And finally, this last component is the matrix inner product of A and A. The matrix inner product of A and A is the trace of A transpose and A, which means that we're doing this. So first, let's start by getting the dot product of these two matrices. And that will be 4, 2, 2, 10. So the trace of this is just 4 plus 10, which equals 14. So now let's take each of these components and add them up. So we have 19 plus 0 plus negative 2 plus root 14 plus 14. And that should give us 31 plus root 14, which is our answer to this problem.